Okay, let's get started. So today I'm going to be modeling a road car. I haven't done one of those yet. I've just been doing off-road. Let's see. Okay, so to start out, we can we can start with the chassis plate for the bottom. But I want to do some active aero, so it's not going to be like a plate per se, but I can get the general dimensions down that I can reference later. Let's see. Okay, top plane. Let's see. The dimensions are. Okay. Wheelbase 259 millimeters and 200 millimeter width. Yeah, so this is going to be a 1/10 scale. So 200 width. And let's see. The length is 438. Okay, and then so grab all these, make them for construction. Let's do another set. They might not be from there. So we can do a corner rectangle. And we want to make this as parametric as possible. So we can go in later and adjust the dimensions accordingly. Currently, since I don't have the body right now, I don't know exactly how far back the front wheel is going to be and how far away from the rear bumper the back wheel is going to be. But I do know the wheelbase. So this wheelbase is going to be 259 millimeters. Then we can take this and we can adjust it. So if you want, you can say, that's good right there. Let's give it a dimension of 75 millimeters, and we can change it later on. So now we can use this as our reference for the rest of the car. Let's go ahead and put in a center line for reference. And then we can save this. Let's do a new folder. RC road car. And this is going to be the layout dimensions. And so what we can do is, let's see. Yeah, let's do it the other way. Let's do it the other way. So I'll take that, I'll delete that. And I'll do the dimension from here. I'll do this one as 75. Okay, so it's going to be front this way, rear this way, left, right. Okay, so exit sketch. Here we are. And so we can take this and we can make an assembly from the part. Okay, it's really awesome. So when we're importing all the other parts, what we can do is we can reference it to this one. And we can also have those other parts reference this specific drawing in the assembly so that we can get all the dimensions right. And now if we wanted to change stuff later, like changing or moving back the position of the front wheel, all we have to do is change it in this reference part. And since it's parametric and we're referencing this specific part, all the rest should change too. Okay, let's see. What else do we want to go with? So, let's see. So if you want to see an image of the picture, the car. So here's the body I got. All right, it's a Ford GT race car. Yeah, and okay, that doesn't work. All right, so this is the actual Ford GT. And this car, this RC car, actually has these channels going through on either side of the cockpit or cab. And we're going to use that to our advantage. We're also going to try to use as much as we can of the current aero and cooling systems so that we can cool the electronics inside as well. Now the undercarriage, it's going to have kind of an interesting geometry so that we can get a lot more downforce without producing a ton of drag. And so we have to be pretty mindful about that too. Like we want air to go under the car, just not an absolute ton, but we want a ton to leave. So that'll draw it down. But we also want to make sure that we cool our electronics because that's, I mean, it's no fun when you can just do a couple of speed runs and then you have to let your car cool down because there's no cooling. So that's what we're doing. All right. So what we can start with are the wheels. So 1/10 scale road wheels. Dimensions. Okay. So let's see, Proline. Okay, not sure. Okay, yeah, offset and all that. Okay, 1.8 inch, 65 millimeter off-road. Yeah, 1/10 scale HSP. Okay, yeah, this is gonna work. So it's going to have a rim diameter of 46 millimeters and a total tire diameter of 65, or no, it's going to be the inside wheel is going to be, inside of the wheel is going to be 46, the outside is going to be 65, and the tire is going to be outside of that. No, that is tire. Tire is supposed to be 65. Okay, that makes more sense now. Okay, so we're going to do a new part. And in order to do a tire, what we're going to do, we're going to hit that top plane. No, top plane. All right, and then we're going to make a revolve function around a center line. And we are going to make our wheel. So this is going to be the outside down here. It's going to be the inside right here. Right here from the middle, it's going to be the wheel hex. And it's going to come out. And then it is going to kind of at an angle, so a slight dish. And then it's going to come out straight for a straight wall. Then, let's see, do we want to make it complex? Sure, why not? Right. And so what you can do is you can zoom in so it's not taking from either of those. It'll come up over here. I'll do the same kind of lip. Come across. It's going to be the internal part of the wheel. It's going to come in. And then finish it off. Okay, so let's see. So generally it's going to be, so B hexagon adapter. So let's say 12 millimeters. And then the total outside is going to be 65. Uh-oh. Let's not work from the outside in. 46. Okay, real deal. Okay. So the wheel is only going to go to 46. So let's see from here. Let's see, let's make this 42. And what we're going to do is we're going to just fix that as it comes. Pull that down, pull that down, pull that in, that. Okay. Okay, so let's get some of these other ones going. So this one, we're going to make it, yeah, probably about 3 mil thick. These guys are going to be about 3 mil. Another 3. And this one's going to be about 3 as well. So we can do for relations, you can take these two and make them collinear. You can make sure that these ones are parallel. Then we can should be able to. Oh, we can't take that. That's right. So 3, 6. You know what? Let's get rid of this one, and that way we can do total wheel diameter is 46. D tire width gonna be 26. Okay. Let's do this guy is gonna be 26. You know what? Let's make this 2. And this one is going to be. That's too much. Let's make it 5. See, how much of an offset do we want to have? How much of an offset is there normally? Okay, entire center line. Sure, we can make a center line. Take this center line, put it there. Alright, so this is going to go beyond the center line. Let's see. Oh, it's connected here. Let's take this coincident. It's not that coincident, okay. Let's leave this coincident. So now we can grab this, bring it up. Yikes. Hey. Lol. Hello there. Ah, shucks. So let's make that 3. What we can do is we can take that, marry these. You know what? I think it'll be fine if we make that very close. Oh, no you. Let's see. You know I'm not. We can make this one 2. We can make this one bigger. It's 8. Yeesh. You can go ahead and delete that. And then make this one horizontal. It's a good knee. Man. That is really funky looking. Alright. Whispery, whispery. Okay, you want me to talk louder? How's this, baby? Okay, okay, okay. 26, 26, 46. Wow, that's really wide. Okay. All right, so this guy, we can make him 3. And what's this one doing? We're gonna make that vertical with that guy. Okay, so now we go to our features, we'll hit revolve base, we'll grab this guy, oh, and it already grabbed the direction it's going to revolve. Open and intersecting, oh no, oh no. Just grab this contour, I swear you like it. Oh, yeah, of course. Use this line, oh, there we go. Okay, here we are. Okay, there's not much going on there. So what we can do is we can go back into the sketch, and if we want to make this hollow, bring this down, take this one, connect that up, and then we can make this width dimension to be 12. Still a bit big. Let's make it 10. Alright, then we can exit the sketch. It's going to remake that. And now we have the starting of a wheel. Still looks a little bit big, so let's take a little bit off of these vertical walls. So let's see, 3 seems like a lot. Let's do 2. Yeah. That's much better. All right, now it's looking like a wheel. So we're going to take the front plane, we're going to make a sketch on it, and we're going to take this and this. We are going to convert them. So we're going to take the geometries into the sketch. We're going to make them construction lines. And then we are going to offset. So we don't need 10 millimeters. How about 3? 3 looks like it might work. You know what? Let's do 4. And then we'll take this one and we'll offset this, reverse. 4s looks like a little too much. Let's do 2. Let's see how it looks from this side. How much do we need? We don't need very much. Let's go with 1. All right, now we can go back to normal 2. And let's start making our spokes. So we'll take a line and say, what kind of spokes do we want to make? What we can do is take center line, go straight up, and then we will grab this line. What do we want to do? Is that what we want to do? Sure, why not? Make it a little bit more narrow. And then same thing on the other side. And so we're going to do this guy, this guy, and this guy. We're going to make it symmetric. So they are essentially the same. And then we are going to do the dimensions. Let's see, 6. Do you want to do 6? Sure, why not? And so now we can take these two. We can do a circular sketch pattern. We want to keep the equal spacing, and we can play with how many spokes we have. 7, 6. You know what? I kind of like 6. 6 is nice. We will select OK. Now, why are they blue? They are blue because, well, they're not joined to the circle. So we're going to join them, make them coincident, make this one coincident, and bam, locks them all in. Let's drag this out so it's a little bit more visible, and same with that one. That's how we know our offsets. And then let's do an extrude cut. We will select the specific contours, so we'll grab that guy, that one, that one, that one, and that one. And we will cut through both sides. So both sides of that plane. Click OK. And now we have a rough rudimentary wheel, 6 spokes. So now we can go in and make some fillets here and here. Yeah, these are going to be different from the others. And let's try 4. No, way too big. 2. 1. Oh, 1.5. Okay, let's do 1.5 there. And for these ones, so do, you know what? I think 1.5 works. So since 1.5 works for the other ones, what we can do is we can go into here, edit this, and we can take these other edges with us, click OK, and then bam, we have those fillets. We will grab this, we will hit circular pattern, direction is going to be around there. 20 seems like a lot. Let's try 5. 5's not enough. 6. And 6 looks like it's just enough. Click OK. Rebuild errors. Oh, yeah, that makes sense. Okay, it doesn't really like that. So what we can do is we can just go back into here, edit this, and just grab the rest of the edges. A little tedious. Still considered parametric because all we would have to do to increase or decrease the fillets is go back into this feature and increase the size right here. Okay, that looks good. So it's not totally parametric, meaning that if I wanted to increase the amount of holes, it might not increase the amount of fillets. So if I go in through, let's see, cut extrude, I edit this sketch, and I say 6, let's make 7, right? Say okay. Exit sketch. Oh no. It doesn't know what's going on. We'll edit the feature. We will grab this. Okay. And bam. But unfortunately, these edges are not included with the fillets. So let's go back. Put this back down to 6. Exit. Yeah, I know. And then we'll have to edit the feature. Deselect this one. Why are you selected? Go away. There. Okay. Now we're good. Oh, yes, please. Thank you. Yum, 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 yum. Oh man, I'm so bad at looking at chat. Yeah. Up my gain. Get them big gains. What even? Dascray, I don't know. I was thinking 3.5. Yeah, 3.5 millimeter might work. Mom and Dad are driving to, okay, to look at the new construction right now. That is freaking exciting. I'm excited. I can't wait to hear. All right. So this is almost complete. All we really need to do is make a hole right here. Let's see, what size is that? Is it 4 or 5 millimeters? 4? 5. Let's go with 5. We will extrude cut through all both. Okay. We'll go back here. Let's make a sketch. We will make a polygon using this as the origin coming out. And yes, we want to have 6. We will grab this guy, make sure that is vertical. And then we will make this 12 millimeters for our 12 millimeter hex. If you wanted to print these out, what we can do is we can go in and put 12.1 millimeters. That way we have a little extra clearance for slipping them on to the wheel hexes. Then we're going to extrude cut. We will do a offset from surface. So we want to make sure, I guess we don't need to do an offset from the surface because the wheel hexes have a specific width. So instead of doing offset, we will just do a blind. And we will put it at, what size are they, 4 or 5 millimeters? Let's do 5. Okay. And then, bam, we have our wheel hex. Let's go ahead and save this as wheel 6 spoke. All right, so now we can kind of clean up some of these hard edges. Let's see this one. It's a bit harsh. We can clean that one up easily. So we can go in and chamfer, hit that guy. Now we can thicken it quite a bit, but we don't need it that thick. That's kind of nice, but chamfer, probably not the best to do for that one. Let's do a fillet. With that, okay, that looks cool. So it's going to slope back a little bit. Let's make this a little bit bigger. Let's try 3 mil. Seems a little big. Let's take it down to, okay, let's do that. All right, that looks good. Let's fill out this space right here. That's a little too excessive. Let's make it 0.5, see how that is. That looks fantastic. And then we can fillet these edges as well. Let's do this guy and this guy. You know what? We don't need fillets. We want chamfers for these. Let's do these as 0.1. How about 0.2? How does that look? You know what? Let's go with 0.25. Here we are. That's looking a little more like a wheel. And then I guess it's fine if it's straight up edge. So yeah, that is a wheel right there. We can go in and edit the material. What do we want it to be? What do we want it to be? Titanium, copper alloy, you want some bronze wheels. Bearing bronze? Let's go with pure gold. No. Let's go with alloy wheel. Easy, good one is 6061. Oh, it's fine. D6, sure. Close. Then we can go over to our property manager over here. We can change our appearance. Let's go to metal. I like bronze. We can make them bronze. And we can make them. Oh, hell yeah, 2 gallons. Thank you. So says one viewer. And okay. Matte bronze. That looks good. Let's save. Let's see. What is this measurement? 42. Okay. So it goes from 42 to 46. Right? Yeah. So it's 42 in here, 46 out here. So let's make a new one. Let's make another part. Let's make the tire. Let's see, if I wanted to do 3D printing tires, I could do something flexible like TPU. Of course, that would be fairly slick. And, oh, it says 2 on my, okay. Yeah, it updates, thank you. I do want to try TPU tires though. It would be kind of a drift car. Not sure how it will accept at the heat when you're going for a while. Might start melting and flinging the TPU everywhere. I guess we'll see. This sounds like it'll be fun to try. But let's make the tire. So same thing, we're going to take our center line, go straight up. This is what we're going to revolve around. Then we are going to, since the tire is not on the inside, it starts on the outside, we can just yeah. So we're going to make essentially the negative of the wheel. We'll go here, here, up, across, down, in, down, end. And then we will do, what was that dimension again? So 26. So it's going to be 26 wide. It's going to start from, so that says, yeah, so it'll go from 42 to 46. Dimension 26 wide. Then it's going to go from, let's do from here. Shift, click. Now we can get what it would be across that center line. This one's going to be 46. And then we're going to do the same thing here. Since it's already selected, it's going to be 42. And then what was the outer? Outer is 65. Wow, okay. 65. Oh. Drifting Lego. Yeah, it's gonna be fun. Fun. Okay, so let's get this guy. Of course, it's still selected. I totally forgot. No, it was 65. 65. Okay. And then let's go back over to this guy. Double click and sketch. So we can see this dimension. So it goes 2 millimeters in on either side. Let's go back. So it goes 2 millimeters in. What we can do is we can just grab that guy, grab this guy, make them equal. We can also make them collinear. Okay, so we're still going up and down like that. So what we can do is we can just say, hey, you know what? Let's make these horizontal. Now it's fully defined. We can go in and revolve base this. It's already selected everything we wanted to. Bam. Okay, now let's do some fillets on this tire. Just grab the outside edge. That looks a little excessive. Let's go down to 2. How does 2 look? As far as tire profile goes, it's not terrible. That was 1.5. 1.5 is okay. Okay. Cool. So now we'll go to 65mm tire. And let's assign these some properties. Rubber. Let's go with natural. NBR. Sure. Yeah, it's good enough. Natural. No, let's do NBR. Okay. I don't like white tires. Hi, Kelsey. All right. I go in, select rubber. What up? How you doing? Yeah, I'm doing good. I'm doing good. How's Nicole doing? Nicole, how are you doing? And how's adorable Knick-Knack? How's she doing? Let's see. Let's do rubber. Matte rubber on the body. I love you. Yeah, you do. We can do tire tread on the outside, just on the face. And bam, looks like there's tire tread. Literally not possible, I know, right? We'll save these. Let's go back into our assembly. Let's save our assembly. Sure, why not? And we'll insert components. We'll do these two, there and there. Let's turn off that sketch. Back to the assembly. And we will mate the faces. Okay. I actually don't like how thick those tires are. So what we can do is we can make these wheels a little bit bigger. Hopefully our parametric modeling will come through and we don't have to redo all of those features. Let's go over here. We'll take this guy. We will go back into the sketch. 46. Let's go a little bit bigger. Let's say 52. Exit the sketch. And bam, still looks good. Looks like it carried over all of our features. See how it looks in the assembly. A little bit better, so we can change the tire. Sketch is going to be, you know what, let's delete that. Let's make it a little more parametric. Make it 2, bam. And then we'll make this 52. A little more low profile. That looks a little better. I think we could still do better though. Yeah, pretty excited for. Oh, yeah. So yeah, I applied and got an interview quite immediately, essentially the same day. I know, Kelsey. It's like we're adults or something. Um, let's make the wheel a little bit bigger. Go back into the sketch. Let's make this 54. Exit the sketch. Then we'll go to the wheel. Make this one 54. Exit the sketch. And go back into the assembly, and that looks a lot better. Okay, wow, that's pretty far away. So, what we can do is take this, drag it down here. Why can't you just go all the way down there? Okay. I did not hear about your job offer yet. You know, I don't think we're ever ready to be an adult. It just happens. And then you do it for so long, and then you're considered an adult. Let's see. All right, so what we can do is we can take, not the tire, but let's take the wheel. We'll take the top plane, and we'll take the top plane here, and we will marry them. Then we can take this guy here, and that guy right there, and we can make them coincident. Then we can get that guy, and that guy, and we'll make them concentric. Oh yeah, break the other mates. Yeah, sure, why not? Sure. Let's go ahead and delete that. Yeah. Uh-huh. I don't know why. This one didn't snap to the top plane. So what we're going to do is we're going to float this. We're going to take the top plane, and coincident, right plane, coincident, front plane, coincident. Bam, right there. Yeah, you don't need to tell me about your job offer until you're ready. Let's take this and this. Coincident. So now it's going to the outer edge of the total dimensions. This, which is the center of the wheel, is right there, in the center of the wheel. So since this wheel is connected to this sketch line, if we go back into this sketch, the layout dimension sketch, and we change that distance, this wheel will change as well. Hooray, parametric modeling. if you want to get better at parametric modeling, I suggest practicing, really. There are things that you can do. I'm sure there's some videos that you can watch, but you'll find out that certain things that you do will make changing dimensions just so much easier. And that is pretty much just parametric modeling. Professorship. Ooh, that's exciting. Houston. That's a little far away. Wow. Texas. Just gonna copy this guy. You know what? Let's just do a shift. Shift copy. No, just not gonna do that. Okay, let's just do that then. Control V. What? All my exes live in Texas. Definitely fall. Yeah, let's not talk about that. Let's see. I'll grab this guy and this guy. Make him concentric. We're gonna take this guy, right click on him, spin him around. Same thing this one, just spin him around. Same thing here. We're going to make this concentric. And this one for Zebek. Concentric. And then we are going to align them to the outside dimension. Wow, looks like a car already. Ah. Okay. Oh man. Perspective. Oh, thank you. Yeah, viewing without perspective it takes some getting used to. Very strange. Okay, so what is next? The next thing we want to do is start designing the chassis and suspension. So since we want this to have active aero, what's going to happen is we want to control the airflow in and out of this. So if air is coming along, we want it to go under the car, and we want it to get bigger back here. And so that will essentially create a low pressure zone underneath and a higher pressure zone on top, and it will like pull the car down. That'll increase traction with the downforce, and you'll be able to go faster. So when we are making our suspension, there are several things that we could do. So we can make our suspension along this same plane. That will in turn make the center of gravity a little bit higher. Or we can lower it and we can still make a chassis plate, but we can have very select cutouts and 3D printed areas that allow for airflow. So we can have something like a CNC aluminum 7075, nice strong chassis plate, and we'll have cutouts for the air to get squeezed down towards the floor. And then we'll put the nice big diffuser in the back. So let's do that. Let's make a chassis plate. All right, so in order to do that, we need to make a new part. So we'll make a new part, and then we'll take it into here. So we'll make some rough measurements, then we'll take it into here. And then we can edit it inside of our assembly. Oh, we still need to make that to the outside. Okay. Okay. So yeah, new part. Rough dimensions. Let's say we want it to be, so we'll have suspension arm coming out here, one coming out here. How far they're going to be, not quite sure. It's not going to be too long. Same thing up front. We need to have enough space to have steering linkages. So let's say we're going to make the arms connect around this point. We're going to make it all-wheel drive. So we need to make sure we have enough space for the front differential. So we'll do this, about this size. And then let's see. As far as the air goes, so it needs to get skinnier, thinner, right around here. So what we can do is we can have the chassis plate a little bit higher and then have a 3D printed section go down a little bit lower to get that squeeze for that low pressure zone. And then we'll have the chassis plate cut out behind here for attaching the large diffuser. Yeah, I'm definitely excited to move back to Santa Rosa. Move back to. I've never lived there, but I'm excited to move there. Okay, so let's do that. Go new, part, okay. Let's see, top plane. And let's start making our design. So what we're going to do is we're going to hit that guy, make it for construction. We're going to, let's see, exit the sketch. We're going to save it. Chassis plate. We're going to go into our assembly. Save it like a good boy. And then we're going to insert chassis plate right here. And then we are going to expand this. Sketch. Edit sketch. Oh yeah, it's not fixed in place. Of course it's not. So let's go ahead and fix this in place. So we're going to take this this. We're going to take this, put it right there. Then we're going to move this guy over, take that one, and this guy, and mate them. Okay. So now it is in place. It's not going anywhere. Now let's edit the sketch. Now we can mate them with the original reference sketch. So we'll make these two collinear. Let's see. This guy, what are you doing? Oh, it doesn't want to move. That's why. Okay. This guy and this guy. Make them collinear. Yes. And then like that guy and that guy. I'm not sure if it's gonna like it. Yeah, it doesn't like it. Okay. So we're going to exit out of there. And this guy, let's see. Oh, the distance there. That is, what was it again? 258? 256? 259, that's right. 259. So we can go back into chassis plate. Chassis plate, okay. And we'll edit the sketch. And we'll make this one. Oh. Yeah, let's go ahead and remove these mates. Yeah. Okay, let's rebuild. Now let's go back to our sketch. $250. Come on now. How's it driven? So what we can do is we can just go in here, grab our chest plate, delete it. Yeah. So now we don't have to worry about any remnants. Then we can go in. Come on. Screw it. Let's just get rid of that. It's a little funky. We can just do that again. It's a good thing we didn't make it too complex. Make it for construction. We can do 259, 200. We'll save. And now we'll be able to bring it into the assembly. All right. Okay, I'm going to take a little bit of a break, but I'll be back in probably about 10 minutes. Alright, I'm back. Okay, so chassis plate. Let's go back to this guy. So he's all made it up. And we will make a new sketch. Top plane. And so let's see, front wheels here, rear wheels here. And so we can pretty much, so let's make a, now we can make it just a straight line. So the wheel will need to kind of turn, but we can design that into the suspension arm. So this is just for connecting the suspension arm to the chassis. So it's going to come out. We're going to have probably a 3D print hanging off or protruding that's going to have the suspension arms. And then, let's see, you can probably do something like this. And we're going to want to make so let's do half, and then we can just mirror. That way we don't have to worry about doing exactly the same thing on the other side. So this one is going to be, I'm not sure if I want just a curve or let's do a spline. So for a spline, make that come out. And so this is going to be the long one. We're going to want to put one here, right here, and then connect it. Here. Oh, we can just connect it. Yeah, let's do that. So now with the spline, we can move it around. And we can take these arms and we can kind of bias it. So we can take these, make them tangent, take these, make them tangent. And so now we can take this guy and we can move it all around and it'll keep the tangency. Okay, so we want to have the front splitter essentially go to the outer edges of the body. So let's take this guy and make them collinear. We can move this little guy up a little bit. And then we'll make these, let's see, so if it's 50 millimeters, it's not going to be very much room for the suspension arm. Or is it? So make a center line. So if we just say from here to here, so 65 divided by 2. And this is going to be 26. And it's going to be 65. And essentially here. So this is a wheel. So what we want to do is we want to make this splitter a little closer. This is also what our wheel well is going to be. Is it going to be though? It's going to be mounted to. So there's a couple different ways we can make the wheel well. We could make it attached to a tire. Benefit of that is we don't have to worry about rubbing too much. And we can keep the amount of unused space for air to get mixed up in. We can make that as low as possible. But one big drawback is it's going to add unsprung weight. And we want to help mitigate unsprung weight. So that means that we would have to have the wheel well be kind of like this bean shape so that the tire can go back and forth and not have to rub. So we can try to incorporate that into here. Let's see. So if I do this and this guy go here, okay. So we'll do, let's say, 45 degrees. Sure, why not? So center line, let's see, 45 degrees. We'll do 26 divided by 2. Make it come out. 65 divided by 2. Make it come over. 26. Make it come back. 65. Okay. So if it pivoted right there, this is how it's not going to pivot right there. It's likely going to pivot. So it's going to be connected here. The hub's going to be here. Then, let's see, we're going to have linkage right here. So the closest we can get it to pivot is probably going to be around here. So we can take this, delete that. This guy is coincident to what? Didn't say. Okay, doesn't like that. So if we go back, let's make the center line here. And we'll do our 26. And our 65 divided by 2, 26. Okay, so that's going to be the front patch. Or close enough. Okay, so it's going to be real close. So what we can do is we can take this guy down to 40. Let's take out that coincident. Make these two perpendicular. Make these two parallel, equal. And now we can bring this out. Let's see, take this guy, connect it to here. Coincident. This one out to here. Okay. So This is difficult. So, in order to get this swing space, we need to have like these dead areas. Do we want to incorporate some of that into the front splitter? Um, Maybe we can add some later. So let's go ahead and keep it a little simpler for now. We can always add more later. So now we can take this, we can go back up to here. We can assume that it's going to swing about the same amount each way. Um, let's see, the floor is going to be as low as absolutely possible underneath the middle of the chassis. So we want to try to mitigate the amount of air that kind of goes side to side. We want to essentially just keep it linear. We want to keep it going straight. So we can have the center bottom of the floor, kind of like in F1 cars, how the pod is essentially the closest thing to the ground. And so we can fix that. We can essentially alter that with a 3D printed aero spacer. And on the sides, we can have it go up. We can even have it go up above the chassis, but we don't need it to go up that far. So what we can do is we can keep the chassis plate as the top, the roof of the floor, so to speak. So we can go in through here, and mind you, we can always go back in and remove or add pieces as we see fit. Actually, yeah, we don't need to have rear wheel steering. Okay, and then our diffuser. So we're going to do another spline here, 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 and essentially go here. So the rear diffuser is going to be pretty big. So we can have it come. So we want it to expand vertically and horizontally. Vertically is going to give us the most, probably the most force. So we don't really need it to expand horizontally. Reference pictures show that it expands both vertically and horizontally. So we can kind of go off of that, what has been previously done. So let's do that. And then we'll come right across and connect our center lines. We will put this guy there. We will make this, since the tire diameter is 65, we want it to be real close, so let's make it 70. That's 2.5 millimeters on all sides. Hey, 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 hey. And let's see. So the rear swing arms, we don't need to have very much back there. So just like the fronts, the rears are going to have these suspension arms. And we're going to have essentially the same tire. We can always, put wider tires on the back. But we want to also make sure we have enough room for the rear diffuser to expand the air that's traveling underneath the car. So what we can do is cut it short. So we will go in, grab these, and delete them. We will also have this be 65. Do we need 65? Let's see, 60. How does that look? $50. So we want to have enough space for the arms to travel. Sure, let's do that. And then, let's see, let's make this guy there. Okay, so this guy, let's go ahead and delete. And so what's going to happen is the diffuser is going to start expanding before the rear axle. And we're going to try to get that diffuser ceiling as close to the rear axle as possible, and then continue expanding. Let's see if I have a reference image. Okay. So we can see right here. So this is the rear diffuser of the Ford GT race car. We can see those cutouts that we can use as additional aero. We can see here that the diffuser does expand vertically and expands horizontally around where the backs of the tires are. But what it also shows is that it doesn't start going up until about where the rear transmission or differential is. So what we can do is cut our chassis plate down to roughly there. So center of the axle. And so this to here, and then across. So remember, these are the centers of the front and rear axles. And so this one is going to be, well, 70 divided by 2, which is still 35. And this one will keep it at 50. Just so we have some overhead to play with rear tire width. And now let's get these dimensions settled in. Let's pull this guy in a little bit. Let's pull this one out a little bit. Let's take these, give it a 45. Take this, and we're going to make it symmetric around there. Oh, shit. Here, here, here. Ah, you're not going to give me symmetry? Okay. Yeah, I need to put a new center line in. Let's go ahead and convert this entity, and take this entity, make it for construction. Now we should be able to use it here. Bam, make symmetric right there. So we can take these two. We can make them equal. Now we can play around with this width and figure out how far we want it. So how far is that? Let's let's make it 105. And this guy, let's make it 60. All right. Looks like we'll have plenty of room. Okay, and so this guy doesn't need to be anything fancy. Let's make it 60. And then let's play around with this spline and kind of get it situated where we want. So we want the front splitter to be fairly wide and cut across. And the car itself, let's see, the body, where's the body? Okay. So the body itself, we can see it it comes out a little bit. It does not have like a full complete radius, but it's somewhat close. So we're gonna have to reduce that flat size and make this spline radius a little bit larger. We'll make this side a little bit flatter. So take this, you know what, let's bring it down to 40 as well. Let's try 50, yeah. And so we'll take this spline, we'll bring it inside, we'll give it a little bit more of that nice slope. We'll bring this back a little bit, let's say 10 millimeters. All right, so this slopes a little bit more. There we go. That's looking a little bit better. Okay. All right, and then let's see, how far in front does it go? I am not certain. So that is 259. This could potentially be maybe 90 or 100. Yeah, let's do 125. Let's see how that is. You can always have a splitter hanging out the front. It's perfectly fine. I mean, the body itself has a kind of a faux splitter right there. Of course, I'm going to be cutting that off. I'm going to be cutting off this front grille. I might be cutting this off too. Hopefully I can get that into the chassis. And then I'll be cutting out this whole rear diffuser bumper section. And that's going to be 3D printed diffuser. Now that we have that, let's go in and mirror this geometry. Come on. There we go. Okay, let's go ahead and re-grab that one. It looks fine. We'll mirror the entities. We'll mirror about this line, except, and then we will extrude. So it's likely this will get manufactured at 1/8 inch, so we can do 0.125 inches, and so that's going to automatically bring it up to 3.175 millimeters. We will say OK. And now we can adjust the material. Likely this is going to be made out of 7000 series, so 775, likely T6 plate. Apply. And so we'll save. We will go back to our assembly. We will see that our chassis plate is now there. Interesting. So it's a little higher than I wanted. So chassis plate. So this shows. Oh yeah, because it's coincident. That's right. Okay, so what we're going to do is we're going to free this up and we're going to lower it. Yes. So let's go ahead and make a reference plane. Reference geometry, plane. We are going to take top plane and we will flip the offset and we will offset it. How does 15 millimeters look? 15 looks like it'll work. Do 15 millimeter offset. Let's take this chassis plate, see what mates we have going on. Oh yeah, they're coincident. Okay, we'll take these, delete those, yes to all. We will take this guy and this guy, and we'll mate these. Cool. Take this and this. Let's see. How do we keep it from going back and forth? So what we can do is, yes. So this wheel, right plane, and we are going to make them parallel. We're also going to take this right plane and this right plane, make them coincident. And then we are going to take, let's see, we're going to take the front plane and this front plane, and we're going to make these coincident. So now, it should be where we want it. And if we wanted to increase this this distance down, what we can do is increase this 20. Okay. And bam, it's lower. Actually, I like that better. Let's do that. And let's flip. You know what? Do we want to keep it like that? So my thinking is, do we want to keep the top of this? So okay, so 20 millimeters away from this kind of center point is a great reference. It's easy to remember for all the other parts that we're going to make, especially with the steering linkage, the suspension arms, all that. But it's going to be the top of this where everything's going to mount to is going to be 20 minus 3.175. So what we can do instead of having this that far away is we can change the mate. So we'll go ahead and grab So this is the mate with that plane. Right click, we'll edit it. We will take this face, we will delete that. And then we will take the top face, oof, and we will reverse it. There we go. And that is looking good as well. Really low. We'll make sure that we have plenty of suspension travel and adjustment so that we can have plenty of ground clearance. So yes, okay, and bam. So now we can go through and get rid of some of these, or at least silence some of these sketches that we won't necessarily need for the future parts. So we'll just hide that. Save. Save. All right. So yeah, so far we have wheels, we have a chassis plate. The next things in the next stream or recording is going to be starting the suspension arms for these and pulling in some of the hardware to mount those suspension arms to the wheels, to the chassis, and all that. All right, thanks for stopping by. If you wanted to check the last stream out, in that stream I made this guy right here. So I don't know if you can recognize this. So this is a BMG clone, and this is a volcano clone. This right here is a hot end water cooler. So if you're into 3D printing and having a heated enclosure, if you have an air-cooled heat break zone, all you're going to be doing is throwing that hot ambient air towards that heat break, and you're going to have heat creep go up. And when you have that heat creep go up, it's going to potentially jam the filament inside your heat break zone, cool zone. So a couple of things that you can do to mitigate that. You can make your heat break out of titanium to help prevent that heat from creeping up. And you can also increase the cooling of your cool zone. So water, absolutely amazing at cooling. Using this, very, very minimal and has plenty of space for the water to actually go through, get a little bit mixed up, a little bit turbulent, take out some of the energy from this area and extract it. And this should be great for cooling that cool zone off. This is a prototype. I made it by hand. If you want, so I have a couple more prototypes, and maybe later I can show them as well. But if some other people are interested in getting some of these, there's also a couple of different variants. I can do a batch order and get them out to you. Yeah, get them made. I can get them anodized to help prevent any type of corrosion. And all you have to do is mount this to a PC water cooling setup. I also have the part numbers for all these fittings that you can get on McMaster-Carr. I could also, get them for you and package them together along with this and send it out. The way this mounts is right there. There is an E3D style adapter that this BMG clone connects to, and that is threaded onto a hollow piece of M6, which goes down in here, and it locks everything in place and has the PTFE tube kind of going down only till about right here. So yeah, super easy, 8mm tube. You can have that go to whatever tubing you have. It's fairly common size. You can use like tubing adapters, or you can use 8mm specifically. But yeah, you can have that going to a radiator, a pump, and a reservoir, and you can get water cooling to your 3D printer. All right, that is it for me for right now. Thanks for stopping by. Check out some of my other videos if you want to see some of the other builds, essentially the ending of a lot of the builds. And with that, thanks again for coming. I'll catch you in the next one. Bye.